Hi everyone, this is Mrs. Pullen for lesson 8.02, and in this problem I'm going to demonstrate how to graph two cycles of the function y equals 2 cosine of 2x. In order to graph this function, you need to understand the basic pattern of the function y equals cosine of x. To get that pattern, we're going to pull off the x coordinates at the quadrantal angles of a unit circle. So at 0, it would be 1. At pi over 2, it would be 0. At pi, it would be -1. At 3 pi over 2, it would be back to 0. And at 2 pi, it would equal 1. We're going to make a nice smooth curve. And there we have the general pattern of a cosine curve. Notice that we only use 5 points to graph this function. We can also look at this function as it's at 0, it starts at the maximum value. It then goes to what we call the midline or the baseline, down to the minimum value, back up to the midline or the baseline, and back to the maximum value. The function, the standard cosine function, has a period of 2 pi. That's when you would expect to see one interval. And we can actually view it as, we can actually break it down into 4 quadrants. So we can divide it into 4. Okay. What we also need in order to graph this function is we need to pull off the amplitude, the frequency, and the period. So let me just rewrite the function here. The amplitude of the function is the number that appears to the left of the function name, and it's always positive, so you're always going to take the absolute value of it. The frequency is the number that appears between the name of the function and the angle input. In this case, x would be considered our angle, and we would just take the absolute value of the number before it, which is just 2. And this really means we would expect in an interval of 2 pi to see 2 curves. The period of the function is when we expect to see the end of one cycle, and we actually have a formula for it, and it's equal to 2 pi over the frequency. So in this case, it's 2 pi over 2, or pi. In order to graph, we would need to now identify the maximum value. The maximum value of the function is just the amplitude. So in this case, it just would be 2. The midline is the baseline. So in this case, it's just our x-axis. So y's are equal to 0 there. The minimum value of the function is going to be the negative of the amplitude. And again, the midline is just the x-axis, so y equals 0, and the maximum value is the amplitude. So when we now have to figure out how far we have to space the points. When it was just the function y equals cosine of x, and we divided the interval, the period of 2 pi into 4s, every point was spaced pi over 2 from each other. But now, now we're looking only at a period of pi, and we need to fit 4, we need to break it into 4s, we're going to have the spacing of our points smaller. Well, how do you determine that? You could reason it out, but you can also use the following formula. So we can calculate the sketch point by taking the period and dividing it by 4. So in this case, our period is pi, and I'm going to divide it into 4ths. That means the spacing between the points is pi over 4. So now let's set up our scale on our grid and graph it. Okay, so let me scroll up. Let me get out a different color pen. On our y-axis in the prior lesson, we said every 2 boxes was 1 unit. That still works in this case because I have enough room. Sometimes you have to change this if you have a large amplitude, but in this case, every 2 boxes still works. On our x-axis in the prior lesson, we said every 3 boxes was equal to pi over 2. That wouldn't work in this case. Since we want to graph 2 cycles, I need enough space so I can graph 10 points. I only have 14 boxes. That means I only have enough space to graph 1 point per box. And so that's what we're going to do. So we're going to graph this pattern and we're going to graph it every box. So let me take out a different color. Let's see, maybe this lighter blue will show up well. And let's start graphing. So we're going to start off at 2, the maximum value. Then we're going to get to the midline, then the minimum value, then back to the midline, and then back to the maximum value. So that's 1 cycle, and let's make the nice smooth curve. That's 1 cycle. So now we want to graph another cycle. So again, we follow the same pattern. 2, that's the maximum. Now we're down to the midline, then down to the minimum value, back to the midline, and then back to the maximum value. Let's continue on. Let's see. And that's our curve, and let's label. But we're not done because we actually have to show we have to label our x-axis so we can identify the scale. Otherwise, the graph is totally incorrect. So how can we determine what it is? Well, we know the period, so here's the end of 1 cycle, occurs at pi. And just so we have a little better understanding of what each of these boxes are, if 4 boxes represents pi, then 2 boxes would represent pi over 2. So what do you think this point over here would represent? Well, that's halfway between 0 and pi over 2. That's pi over 4. That's your sketch point. And just so we have a little bit of better understanding, what's this x value here? Well, that's just 2 pi. Okay, so that's the graph of y equals 2 cosine of 2x. We see 2 curves in 2 pi. The end of the first curve occurs at pi. The altitude, that distance from the baseline to the maximum value, is 2, and the baseline to the minimum value is also 2.